right, go ahead and look at the packet that's right in front of you. These Ferris wheel problems, we're going to start off with a couple Ferris wheel problems. These are very, very common when you deal with trig and story problems and stuff like that, okay? So we want to make sure that we understand the way that the Ferris wheel problems work, okay? Oh, sinusoid? Sinusoid, it's just a sine equation. Sinusoids are sine or cosine equations. It's one or the other. So it's one word that represents both. Yeah. All right. So a Ferris wheel. Did I not put enough at your group? They're up there on my little. Sorry about that. So it says a Ferris wheel. Katie had it. See, I didn't miscount. I counted correctly. A Ferris wheel at an amusement park has riders get on at the bottom of the wheel, which is 3 meters above the ground. So we're going to go ahead and label this. This right here is 3 meters. The highest point of the ride is 23 meters above the ground. The ride takes 40 seconds to complete 1 revolution. Okay, so here's how we draw a graph of what's going on. We say that the person gets on the Ferris wheel and they are at a height of 3 meters. That's where they get on. And then if you think about it, as the person is riding, they're going up higher, 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 higher into the air, up into the air, up into the air, and they get to the top. And then they go back down again. So that means the graph is going to go like this. It's going to go up in the air, and then it's going to come back down again. What does that remind you of? A cosine graph that's upside down, right? So when we do these Ferris wheel problems, we are typically going to write the equation of a cos graph that's upside down because it's the easiest way to do these problems, okay? So at the very bottom, they were 3 meters above the ground. At the very top, how high above the ground were they? 23. Okay. So we need to figure out what the midline is. And we need to know what the amplitude is because we're going to write an equation that models this situation. So what's the distance between 3 and 23? 20. So 20 is what the diameter of that wheel is. It's 20. And what's half of that? 10. So that means we have an amplitude of 10. It goes above the midline by 10. It goes below the midline by 10. So if you have an amplitude of 10, then what would the midline be? 13. 13 would be right in the middle. Okay, so we have our amplitude figured out. We have the midline figured out. The next thing that we need to figure out is what the period of the graph is so that we can figure out what our b value is. So what information did they give you in the problem that tells you how long it takes for you to go up in the air and come back down again? 40 seconds. So the period of the graph is 40 seconds. That means the very highest point happens at 20 seconds. Okay, so what we're going to do to figure out what the b value is we're going to say 20, not 20, I lied, 2 pi divided by b equals 20. 2 pi divided by b equals 20. And how can we solve for b? So I'm going to multiply the b to each side. 2 pi equals 20b. And then what do? Divide by 20. 2 pi divided by 20 equals b. And so what does b equal? Pi over 10. Yeah. Okay. So they're saying write an equation that models the height in meters of the rider on the Ferris wheel over time in seconds. So what we're going to do is we're going to write an equation with h's and t's because that's very common for these types of problems. So I'm going to say h of t equals, so that means that t is kind of like my x value, h is kind of like my y value. And then we're going to go ahead and write this cosine equation. So what should I write? negative 10 for my amplitude, and then cos. Oh, we did it with 20, not 40. You guys, correct me. Sorry. It's a quick fix. Well, so that's supposed to be 40. That's supposed to be 40. That's supposed to be 40. That's supposed to be 20. Ooh, sorry about that. I wrote down the halfway point and it threw me off. No, the 20 is part of the B value. So this is the amplitude. We still have the right amplitude. Okay, so now we have to figure out what goes inside the parentheses, and what would that be? But we're going to use t for this problem, right, for h of t. And then what do we put on the end? Plus 13 for the midline. Okay. All right, so now it says at time t equals 5 seconds, how high off the ground is the rider? And that's what h represents. It represents how high off the ground the person is. So we're going to say h of 5 is negative 10 times cos of pi over 20 times 5 plus 13. And this is just a calculator problem. You just have to plug it in. Now, before we plug it in, we are going to be hitting the cos button, which means that the mode of the calculator has to be correct. So based on the calculations we've done, which mode should we be in? We should be in radians, and I'm going to show you, and you're going to circle this on your paper. The reason that we should be in radians is because we said that the period was 2 pi. If we had said that the period was 360 degrees, then we would have been in degrees. But we said 2 pi, and that's why we have to be in radians, okay? So every time we do one of these problems, we're always going to do 2 pi divided by b, and that means that every time we do one of these problems, we are in radians, okay? So I'm going to go back down here, draw an arrow, make sure I don't forget radians. Okay, so if you have a calculator, go ahead and type that in. Make sure you're in radians. If you don't have a calculator, maybe go grab one. You are going to need it for these types of questions. And we can go ahead and round to 3 decimal places. So 5.929 meters above the ground. Normally I would say you have to write a sentence, but I'm going to be honest, I don't feel like writing sentences today. So I'm not going to require you to write sentences. You're welcome. Laura, you got to turn the music off. You got to have, yeah, there you go. All right. We ready for the next one? Okay. A Ferris wheel has a diameter of 80 feet. Riders enter the Ferris wheel at its lowest point, which is 6 feet above the ground. Okay, so let's go ahead and draw our picture. You get in at 6 feet above the ground. The diameter of the Ferris wheel is 80 feet. So do I say that 80 is the very highest it can go? No. I say 86 is the highest it can go. Okay, so if we can picture this, let's go ahead and draw a little Ferris wheel off to the side here. So there's like the stand that the Ferris wheel is on. So they're saying that this right here is 6 feet off the ground. They're saying the diameter of the Ferris wheel is 80 feet. So if we think about how high you are at the very highest point, that is why you would be 86. Because it's the 80 for the diameter plus the 6 feet off the ground. That's how you determine the highest point. Okay, so if we keep drawing this, we know that we're going to go up in the air on the Ferris wheel and come back down. We know that our highest is going to be 86. What is the amplitude for this problem? The difference we said was 80, right? That's the diameter. The difference is 80. So the amplitude would be 40. And if you notice, the amplitude is the same as the radius of the Ferris wheel, okay? So if that's 40 and that's 40, what's the midline? 46. Okay. And then it completes one revolution in 67 seconds, and so that's the period of the graph. And so to figure out the b value, we're going to do 2 pi divided by b equals 67. And then what do we do? Times b times b. So 2 pi equals 67b. Divide the 67. 2 pi over 67 equals b. And so now we have all the information we need to write the equation. So I have y equals, close, negative 40, because it's upside down, right? Negative 40 cos. You're closer than you knew. And what goes in the parentheses? 2 pi over 67. And it looks like they're not doing x's and y's, they're still doing a t down here. So I'm going to go ahead and change this to an h. I went to y as a default. H of t. I'm going to go ahead and put a t in there. And then what do we put on the end? Plus 46, and that's the midline. Okay. At time t equals 62, how high off the ground is the rider? So that means I just need to plug in 62. So really, when you do these problems, you just have to kind of interpret what the amplitude is and what the period is. And the amplitude helps you find the midline. And once you have all that information, you can write the equation fairly easily. Okay? All right. Go ahead and turn the page once you have the answer written down. So the next one gives you the equation, and now we're going to answer some questions on it. So go ahead in there. There's a typo. That should have a negative in front of the 40 because we know the Ferris wheel equations, it has to be upside down. So there should be a negative right there. And I'm going to have you guys work on this in your groups. Okay, because I think you can answer these questions. They gave you the equation, now they're having you answer some questions about the Ferris wheel, and I think you guys can probably answer those. It's just a slightly different way of thinking of what we just did. Okay, so go ahead and work on those in your groups.